Hello, everyone. My name is Joe Filipazzo. I'm the JWST ETC mission lead. I'm going to tell you about what's new in Cycle 6 for the exposure time calculator. So similar to what Carla was saying, this is not a demo of the ETC. This is just updates as to, since Cycle 5, things that have been implemented in the ETC since the last release for ETC version 6.0. So to begin to, the ETC is a simplified data simulator that performs signal-to-noise calculations for all instruments and modes on JWST. The thing we like to tell everybody, it is not a full simulator. Some people are like, why isn't it doing exactly everything I want to do with JWST? It doesn't do that, but it's a very powerful tool to help potential JWST users determine feasibility of observations and estimate the quality of data that they might obtain for a given set of observational parameters. So most of the things I'm going to mention today were already previewed by Stacy and Carla, but mostly what Carla was saying, because the ETC feature development, we mirror the development of APT. So a lot of those new features and stuff you're going to hear me repeat, but this is how they'll look in the ETC. So with that, let me see here. This is just a screenshot of the lovely ETC homepage for version 6.0. Has a bunch of helpful links on it, including, as you mentioned, there's videos available to guide you through some of the basic operations and some of the more complex ones. There's the read the docs, tons of documentation about how to use all of the, basically every single thing on the ETC. And then there's the JWST tool that was also previewed earlier by Stacy. So please click through these things. Known issues, release notes has all the details you would need to see the specifics of the stuff that I'm going to mention today. So, as I said, we support all modes of JWST, including the newest ones. So one of the newly available ones is the NearSpec Bots Prism multi-stripe mode. So this can be used to obtain these long baseline time series spectroscopy. It's from 0.6 to 5.3 microns at a resolution of about 100. And this can be accessed just by creating a NearSpec Bots calculation, and then you can select the new appropriate subarrays from the drop-down menu in the Detector Setup tab. So speaking of subarrays, again, these were mentioned earlier as well. So version 6.0 of the ETC also offers 7 new multi-stripe subarray options for near-cam short wavelength and long wavelength imaging and time series modes. These are the ones listed here. And similarly, when you create a calculation using one of these modes in the detector setup subarray dropdown menu, you'll see the new superstripe modes available. And then, so for people who don't know, so these are particularly useful. The whole idea behind the superstripe modes is reading out the detector in small chunks. So this can increase your bright limit, so you're not saturating your detector, since the read time is much, much quicker. And so for these particular subarrays, you can increase your bright limit of your target by a factor of, as small as 2 to up to 200 times if you're using the smallest stripe size. So it's a very powerful tool to really increase the number of targets that you are potentially visible by these particular modes. So we've also added support for the MIRI imaging subarrays and for LRS slitless TA verification. So these are also mentioned, the slitless prism, IP, and IPS modes. So these are, more specifically, they're basically resized subarray options that eliminate that 390 hertz electronic interference issue that was seen with the previous one. And so then we've also added a warning message that shows up here, the orange text down below. And the orange text just reminds users that their science and TA subarrays must match when using these particular subarrays. So continuing with MIRI, again, this was mentioned as well. So a new readout pattern is available, and that's the fast group average 8 readout pattern. So this readout pattern is essentially the fast R1 readout pattern, but it averages every 8 frames into a single group. which offers better read noise than the slow R1 readout pattern, but better data volume than the fast R1 readout pattern. So it's a very powerful new readout pattern that Miri's made available. And then it's also, right, so the other thing we did was that the number of reset frames for this readout pattern was now 1, where it was, I forget, it was variable or 2 earlier. So we've also made a number of background modeling improvements with version 6. So the sky background correction below 1.2 microns. So this was actually made available in version 5.1, which was the off-cycle release. This was made available in February. The ETC does a release in time for the call for proposals, and then we do a mid-cycle release too, and just in case there's any, really needed and asked for feature development improvements. So in the 5.1 release, this was something that was made available. The better the sky background collection below 1.2 microns. So the ETC now uses this improved model of the sky background at wavelengths shorter than 1.2 microns. And this provides just more accurate background estimates and then more reliable sensitivity and exposure time calculations in the short wavelength near IR. The second one here, so there's new MIRI, MRS, and MRS time series thermal background. So the ETC includes updated mode-specific models of MIRI's thermal background for MRS modes, including the time series observations. And this just provides a more realistic estimate of the thermal emission that limits sensitivity at longer MIRI wavelengths. So again, this is just the thermal background, not the aperture background that typically you can change the settings of in your ETC interface, where you can select. You can select low, medium, or high background levels. This is not that. This is just the thermal background that is also applied before you get to that step. There's also the MIRI imaging thermal background. So along with that other update, MIRI imaging calculations now incorporate their own improved thermal background as well. And then the last one is for the nearest source background. So previously, backgrounds were only accounting for order 1 from contaminants in the background calculation inside the ETC, and we've updated it now to include orders 0, 1, 2, and 3. So again, it's just a much more accurate simulation of the background when you're doing your near source calculations. Version 6 also includes several interface and usability improvements. For cycle 5, we re-enabled encircle energy as an extraction aperture. So what this does is, rather than define your aperture radius in units of arc seconds, when you click on the aperture radius radio button here, you can define it as encircled energy, the percentage of encircled energy that you would like your aperture to enclose. So one of the updates that we include here is, seems small, but it's this text that's right below the field, the text field. And what this shows you is what the approximately equivalent value in the other aperture radius selection could be. So in other words, if I click on this radio button for my source and I want to use an extraction aperture that encloses 80% of my encircled energy for my target, you'll also see that that aperture radius is approximately equal to 1.781 arc seconds. And then if you click on aperture radius, it does the opposite and tells you what your approximate encircled energy is. And this is just a little usability improvement that we added so that users don't have to be clicking back and forth and redoing their calculations over and over. Something else that we added was per stripe values for multi-stripe modes. So that's in the reports pane after you've done your calculation. So one of the, since enabling any of the multi-stripe modes, one of the difficulties has been unclear language essentially as to what some of the values in the reports pane refer to. So people weren't sure if the reported SNR was for a specific stripe or if it was for the entire subarray when you're using multi-stripe modes. And this now makes that clear because we're explicit about which values are being reported in different lines. And these new values only show up when you're using the multi-stripe modes to reduce confusion for all the other modes as well. Let's see. Yeah, so we also did a number of improvements to default parameters. So default calculation parameters, including like aperture sizes, subarray selections. So for nearest, near-chem, and near-spec, these default values for calculations were updated. And so just what this means is when you, in the ETC, click to create a new calculation with one of these instruments, the values that are preloaded into the calculation, just as the default value, are more closely aligned with either the instrument team's recommended strategy and use for that particular mode, or just sort of the most used options, just to reduce the number of clicks and typing that you would have to do. Of course, all of these things are still editable. This just changes the default calculations to the most likely way that a user might be using one of those modes. So also with a new release of STPSF, which generates the models, the PSFs, for all of the instrument modes on JWST, we've used the new PSFs and we've generated our own new PSF library for all of the instruments for JWST, and these are now available. And these are not something that you interact with directly in the ETC, but they are things used in the background to calculate all of your SNR values, so that these are more accurately reflect the PSFs we see on Sky. This results in more accurate SNR calculations. And so then those sensitivity plots that are available on JDocs and in other places, those reflect the new PSFs that we've implemented. For people dealing with planets, the Uranus and Neptune spectral templates were updated. And then also, Carla mentioned as well that some of the, there are new APT samples available for users. We've done the same thing with the ETC. So we have a drop-down that contains sample workbooks and science example workbooks for all of the instruments. But specifically the nearest wide field spectroscopy sample and science workbooks have been updated. And then, as we mentioned, for the multi-stripe mode, NearSpecBots Prism and NearSauce Multi-Stripe have brand new sample workbooks that can walk you through step-by-step how to produce an ETC workbook for those particular modes. So just to let everyone know, as we said, we are here to help. There's a variety of resources available to you if you get stuck doing anything with the ETC. There's the JWST user documentation, JDocs. There's video walkthroughs, as we pointed to before. All of this is available through the homepage of the ETC, as well as a number of other places. Please do check the release notes for version 6.0 and the known issues for previous things before you file your help desk call. And then if you don't find your answer there, please file a help desk call. As Carla said, she sees all of the APT help desk calls. If you file a JWST ETC help desk call, I will personally be reading it and be happy to help you. So please don't hesitate to reach out if you have any questions.